All right, chemists, we are now getting into carbon chemistry, which is just another name for organic chemistry, which is just the chemistry of carbon. And so we'll be looking at alkanes and cycloalkane nomenclature. In this video, you should be able to recognize and name simple hydrocarbons, name and draw alkanes and cycloalkanes. So carbon's amazing because it can reach an octet of electrons by forming 4 single bonds, forming a double and 2 single bonds, forming 2 double bonds, forming a triple bond and a single bond. And carbon can have so many different shapes such as tetrahedral, trigonoplanar, or linear. Carbon has so many options for bonding and shapes. It has its own branch of chemistry called organic chemistry. A hydrocarbon is a compound that is made up of only carbon and hydrogen. This class of compounds are so special that they have their own special names. Alkanes, cycloalkanes, alkenes, alkynes, aromatic compounds. These are all different hydrocarbons. First up, we will talk about alkanes. So we can recognize an alkane because they have single bonds between carbon atoms. The general formula to figure out if it's an alkane or not is to use CnH2n plus 2, where N is the number of carbons. For example, methane. So you can see there's 1 carbon, and then if you were to figure out the number of hydrogens based on that, it would be 2 times 1 plus 2, right? So that's what gives you 4. That's what methane looks like. Ethane looks something like that. Propane looks something like that. Butane looks like that, right? And so we say that these alkanes are saturated, okay? Meaning that they are carbons that contain only single bonds, like in this case, 4 single bonds. It's important to note those prefixes because you are going to need to apply those a little bit later on. So I don't know if you want to highlight them or just put a star near them because you're definitely going to need to know them because you'll be using them a lot. Now, we'll be focusing on alkane nomenclature in this video. So basically how to name alkanes or how to draw the structures when given the name. So whenever you are naming an alkane, we use prefixes and add the ending ane. So for example, C5H12, right? This is just what we call a straight chain hydrocarbon where all the carbons are connected to each other in a line. This is called pentane, right? Pent meaning 5. And then we've got hexane, and heptane, octane, nonane, and decane, right? So again, these are prefixes that you're going to want to commit to memory and make sure that you recognize the ending ane represents an alkane, where we've got all single bonds. There are certain rules that we utilize with naming alkanes, and they can get pretty complex. So we're going to keep it pretty simple, but the first kind of step into naming nomenclature of alkanes is we want to identify the longest carbon chain. So you need to make sure that you count the carbons consecutively, and you can count in any which way. So you just want to make sure that you're counting in all directions to get the longest chain. Anything branching off that longest chain is called a substituent, and then that longest carbon chain has a special name called the parent chain. When you're constructing your name, we have to identify the substituents first, and usually we do this by a number. So we'll include a number and the name of the length of the substituent on that longest carbon chain. You have to number your carbon atoms on your longest chain so that the substituents that are hanging off of the chain have the lowest numbers possible. And then your substituent group names are derived from their hydrocarbon name. So, for example, remember methane with just 1 carbon and 4 hydrogens. In this case, when it's a substituent, it's going to be called methyl. And if you have 2 carbons, instead of ethane, it's going to be called ethyl. If 2 or more of the same substituent groups occur, then the prefixes di and tri are added. And don't worry, I'm going to show you examples of all of this stuff. And then when different substituent groups are present, they are generally listed in alphabetical order. But here's the trick. Those prefixes that we talked about in number 5, the di and tri, are not part of the alphabetical order. So that gets a little tricky. So like, let's say you have dimethyl and let's say you have, triethyl. technically, even though T will come after, really the triethyl would go first compared to the dimethyl. So I'll show you an example. So it's time to practice these rules. So we've got this molecule, and this is a line angle formula. Remember, all of the end points there that you see and the intersection as well as the corners represent carbon atoms, and the hydrogen atoms are implied. This is just a shorthand way to write these structures. So we're going to first identify the longest chain. So I find that counting in every direction is the most simplistic way to do this. So I just literally count carbon atoms. So it looks like, to me, 4 would be the longest chain. So that means that the parent name is going to be butane. Remember, A and E is for the parent chain when it's an alkane, all single bonds. Then we're going to identify the names of the substituents and their locations. And so this is where I'm going to start numbering. Remember, the substituent needs to have the lowest number. So I'm going to start numbering on the left-hand side, and that's going to be carbon 1. The substituent is going to be carbon number 2, and then 3, and then 4. Notice I did not start numbering on the right-hand side, because if I did that, then the substituent would have a designation of 3, and we don't want that. So in this case, in carbon number 2, we see that there is 1 carbon hanging off of that main parent chain. So therefore, that's going to be called methyl. So in here, we call it 2-methyl. You're going to separate the numbers and the words by using dashes. So this is, you're going to put these two things together, and this is going to be called 2-methylbutane. Here's another example. Again, we have a line angle formula. We want to identify the longest chain and give it its parent name. So I'm going to count them. So it looks like 1, 2, 3, 4, 5, 6. Looks like that's the longest. So this is called hexane. And then I have to identify the substituents, and you want to be careful here. So I'm going to start numbering on the right-hand side because I can again have the substituents being designated 2. And then I'm going to number the rest of those carbons. Beautiful. And then you have to be careful here because on the 2, carbon number 2, you have 2, I guess technically substituents, right? You've got 2 methyl groups. So guess what? You need to write this and designate each methyl group as its own individual substituent. So what we do is we show 2, 2. So we're separating the numbers with commas. So it's 2, 2 to represent the fact that there are 2 separate methyl groups. And then we say it's dimethyl because there's 2 methyl groups on it. And then it's methyl because obviously there are 2 single carbon atoms. And so we'll put this together to be 2,2-dimethylhexane. Let's try this one. So again, we'll identify the longest chain. So it looks like this is going to be heptane, right? 7 is the longest. And then again, we want to make sure our substituents have the lowest number possible. So I'm going to start numbering on the left-hand side. And so in this case, our substituents are at carbon number 2 and 4. So I'm going to have 2, 4, and then again, notice they're both methyl groups, so it's 2, 4 dimethyl. And then as far as our name, 2, 4 dimethyl heptane. There is another class of compounds very closely related to alkanes, which are called cycloalkanes. And if you're thinking cyclo meaning circle, you'd be right. So these are formed by tetrahedral carbons that join together to form a ring. And so the general formula is CnH2n. Notice that the +2 has been omitted. And we name these by using the prefix cyclo. So for example, this has 3 carbons, right? We can see that it's a triangle. It makes 3. There's 3 carbons in there. This is a line angle formula for the cyclic molecule. So this is called cyclopropane because there are 3 carbons and they're all connected in a ring. If I were to ask you to draw this, draw 1,3-dimethylcyclopentane. To draw something, I find it's really easy to, again, start with the parent chain. So I'm going to draw cyclopentane, which looks something like that. So it's 5 carbons, right, all connected to each other because it says cyclo as the prefix. And then I need it to be 1,3-dimethyl. So You can really start the 1 anywhere. So now the structure will look something like this. 1, 2, 3. So I'm going to draw methyl groups at the 1 and the 3. So that is the 1,3-dimethyl cyclopentane. Now it's worth noting that cyclo-related molecules, a lot of them are strained, which means that there is a lot of bond strain, that it's pretty high energy, that the bond angles for some of these molecules are much less than 109.5. So these bonds are extremely weak and can break really easily. So for example, with the cyclopropane molecule, that's a very, very strained hydrocarbon. And so therefore it's very difficult for these molecules to form, and they break apart very easily because their bonds are so weak. So if you have questions, make sure you can run them by your teacher, and I'm going to ask you to start worksheet 3H, where we start naming our hydrocarbons and cycloalkanes and alkanes. Thank you so much for watching.